All right, so today we're going to be solving exponential equations. So this is part one. We got a bunch of different ways to do it. So the first one is if we have the exact same base. So this is 3 to a power and 3 to a power. So all we do to this is we solve the powers equal to each other. So you have 2x minus 9 equals 7, and we're going to solve it. Add your 9 and divide your 2. So these are both bases e. So you're just solving the exponents equal to each other. Added your 2, added your 1. So down here, this is a same base. I first need to add my exponents over here. So I have a c plus 3c, negative 1 in that. Now we have both the bases are the same, so just solve your exponents. So subtract my 4, subtract my 16, so c equals negative 5. So over here, I'm going to add these exponents. Makes 3k. Add these exponents. So now we just have 8 to something and 8 to something, so solve the exponents equal to each other. So there's a square and a regular, so set it equal to 0. So subtract over the 4, subtract over the 11. Factors of negative 20 to get negative 1. Oh, these are k's. So k equals 5 and negative 4. All right, next one, we don't have the common base. So what you want to try to do is to try to make them the same base, and then we can do the exact same steps up there. So we have 9 to a power. Well, I can rewrite 81 as 9 squared. So now I have 9 to a power equals 9 to a power. So I can just solve my exponents equal to each other. So add over my 26 and divide my 4. You can always plug these back in also and check if you'd like. So this right here is the same thing as 64 to, well, first let's rewrite 64. So 1 over 64 would be the same as 1 over 4 cubed, right? Because 64 is 4 cubed. And then I want 1 over, so I'm going to put it back on top by making it a negative exponent. Now it's 4 to a power and 4 to a power. So I get, add my 4. So then a equals plus and minus 1. So this is 2 to a power, so I have to write 32 as 2 to a power. So 32 is 2 to the 5th. So 32 equals 2 to the 5th, so I'm going to replace that. Remember, a power to a power, I'm going to multiply these together. So then it's just 5m plus 15. So it was 2 to a power and 2 to a power, but the power to powers we multiplied here. And then to solve, subtract over your m, subtract over your 15. So m equals negative 6. All right, so this is, oh, it looks like this is supposed to be a 12 here, not, I was thinking, how am I going to, I mean, I know how to make 12 into 2, but that was really hard. So this is really supposed to be a 1/12. So really all I need to do is write this as 12 to a negative 1 times 12 to an x squared. So multiplying your negative 1, then add. So I get x squared minus 4x minus 3. Now same base, I'm going to go ahead and add my exponents, or I mean set the exponents equal to each other. So make this equal 0 now, because there's an x squared and a number in there. Oh, this is supposed to be a 13. I don't know how to write. So factors of negative 16 to get negative 6. Minus 8 and a positive 2. So we get 8 and negative 2 there. So let's go ahead and flip this onto the back. So again, this is just more practice. This right here is the same thing as 7. So 343 equals 7 cubed, and 49 equals 7 squared. So this right here is going to be rewritten as 7 cubed. This would be a negative because it's on bottom, so I'm going to put 7 to a negative 2. So go ahead and multiply in. So it's really 3 times that, and negative 2 times that. All right, we're just multiplying my exponents. So add that over. add that over. So n equals 1/4. So 8 is a power of 2, and so is 127. So 8 is 2 cubed, and 128 is 2 to the power 7. So I have 2 cubed, 2 to the 7th. So multiply your powers together, and then solve. So these are all powers of 3 right here. And if you're unsure, like you're just going to have to know your powers, like try, see if like 9 squared, 9 cubed gives you that number. It doesn't. So then you have to try other numbers. Okay, well, I know 9 is 3 squared. So see if you can get this as 3 to a power. And that's the only way to really figure out what they have. The base is going to be the same. So this is 3 squared. And this is 3 to a power of 5. Same base. I'm going to multiply these exponents and set them equal to each other. That's 10p. So let's add that over. So divide, and I get negative 2.5. All right, so these are all multiples of 5. So this is 5 squared. And then this is 5 to the 4th. And then this would be 5 squared, which is on the bottom, so I'm going to put it to the top to make it a negative. So add these together. So this is going to be 4a plus 12 right here. So then add them together, and this is an a. So this is 2a. So 2a and 4a. So I get 6a plus 12 equals negative 2, and then solve. And then divided it.